More specifically, it's going to be the percent composition of compounds. Okay, y'all, there's 10 people in this room. How would you figure out what percent of the people in this room are male? You'd count them. Okay, how many males are in the room? 6, right? There's 6 males in the room. There's 10 people in the room. What percent of the people in this room are male? 60%. What percent of the people in this room are female? 40%. How did you arrive at that? Well, you knew it's only male and female, right? The total's got to be 100. But it's real easy, since there's 10 of us, to count and say, okay, 4 divided by 10 is 40. So in other words, y'all, to do a percent, you are saying part divided by the whole times 100%. Right? Okay. When we do percent composition of compounds, it's the same thing, but it's not a count. Okay, we counted people. When we do percent composition of compounds, it's a by mass percent. So we've got to use the molecular mass to figure out the percent composition. Let's start by doing potassium sulfate. If I say potassium sulfate, do you know that formula?
KSO4.
Close. What did you say, Caleb? How about K2SO4? Does that sound good? So let's calculate the percent composition of each element in potassium sulfate, and we've just figured out that potassium sulfate is K2SO4. So what do I have to do first? First, I've got to break it up and say, okay, there's 2 potassiums, 1 sulfur, and 4 oxygens, and calculate the mass for each of those. What's potassium? What am I going to write?
40, 39.1.
Yes, 39.10 AMU. I get that from the periodic table. For sulfur, 32.07. And oxygen. Now that I've done a few of these, do y'all have to look at oxygen, or are you remembering it now? Remembering that it's 16. You're going to get that way with a lot of them, where you don't even have to look up there. And I punch them into my calculator, and I get that the molecular mass is 174.27 AMU for the total? Okay, to work the problem, calculate the percent composition of each element in potassium sulfate. Well, guys, to figure out the percent potassium, there are 2 potassiums, and each potassium is 39.10 AMUs. Percent is part divided by the whole. That's the part. That's the potassium. What's the whole? 174.27 AMU, and I multiply it by 100%. What do you get for percent? 4% potassium.
45.
Yeah, 45%. I'm going to go ahead and hang on to the decimals, and I've got 44.87% for potassium. Now you set up sulfur and oxygen and work those out. I've got sulfur and oxygen set up for you. Do y'all have the percent sulfur calculated?
18%.
Yeah. 18.40, is that what y'all have for sulfur? What'd you get for oxygen?
37%.
Yeah. 36.72% for the oxygen. Is there a way I can check what I have?
Add them all together.
Mhm. Yeah, I can add them all together.
99.99%.
And we've got 99.9, is that what you said? 99.99, that's close enough to 100. So they should all add up to be 100%. Guys, would 99.1% be close enough? No. They need to add up to very close to 100. In other words, 99.99, maybe 100.01. A lot of times it's going to be exactly 100. If it's anything further than that, you need to look back at what you've got, because if there's a hydrogen in there, since hydrogen has an atomic mass of 1.01, if you just miss one hydrogen, it's really easy to throw it off and make it be 99, and it doesn't seem like a big deal, but that's a big deal, because that means you missed a hydrogen. And it's so small, it's not going to throw it off that much.